Hi, this is Math 2, Unit 13. This is one of the review sheets that you may have had passed out in your class. There are two reviews hopefully posted up online for you. One is the review worksheet, and this is the whiteboard review. So first of all, what are a couple things we know about probability? One of the things we know is that it can range from 0 to 1. That means that all your probability is within 0 to 1. It's not going to be less, not going to be greater. It can never be greater than 1. It stops right there. If it has a probability of 1, as close to 1, it is likely to happen. That means it's almost 100% chance. If it's a 1, it's a 100% chance that it will happen. Okay? If it's close to 0, it's unlikely. So that's how it changes there. So the smaller the number, or the decimal or fraction, the less likely it is to happen there. Okay? The definition of probability is the likelihood, okay, the likelihood or the chance of something happening. Okay? That's what it means. So what are the odds? What are the chances? That's what we're talking about. We're talking about probability there. Number 3, let's get on some problems here. The Manning family is going to have 4 children. How many different outcomes are there for the genders of the 4 children? Okay? So we're going to have 4 kids. Let's call them kid 1, kid 2, kid 3, kid 4. Now for the first kid, it could be a boy or a girl. That means there are 2 choices. The second one, boy or a girl. Third one, boy or a girl. Fourth one, boy or a girl. So 2 choices each time, and so using the fundamental counting principle, the number of different outcomes you could end up with would be 2 times 2 times 2 times 2 for a total of 16 different outcomes are possible for how their kids could come out. Okay? If you want to know more about that, maybe look at some genetics. Okay, events C and D are independent. That means they're not connected to one another, right? They're separate, mutually exclusive. If the probability of C is 0.1 and probability of D is 0.7, what is the probability of C and D? And remember, when it says C and D, that means we're going to take the probability of this one, 0.01, and we're going to multiply it by the probability of D. Let's try it, 0.01. Wrote that wrong. Apologize. We'll take the probability of C, 0.1, and multiply it by 0.7. When I multiply those together, 0.1 times 0.7, I end up with 0.07 is the probability of those 2 independent events. An example of an independent event would be something like a coin flip, right? It's independent, it just does its own thing. I do it again and again. If I get ahead the first time, it doesn't change what could happen the second time. A dependent event would be something like a number 5B, where you put like, you have a bag, and maybe you have some marbles in the bag, right? You have some dark marbles and some clear marbles, whatever. And if I pick one out and I don't replace it, then what happens the second time I pick will depend on what happens the first time. That's a dependent event, where it depends on what happened the first time. Okay, moving on to the next page. We have a bag of marbles, and we have 10 blue, 4 white, 16 red, 14 green, and 6 yellow. 50 altogether. I want to find the probability of one marble chosen and write it as a fraction in reduced terms. So first of all, probability of green, there are 14 green out of a total of 50, and that can reduce down to 7/25. For blue or white, I would do this. Blue is up here at 10, or means to add, and white we're at 4, and it's still all out of 50. So that becomes 14 out of 50, or reduces down to, again, 7/25. For number 10, we have yellow, which is 6, or plus red is 16 out of 50, which is 22 out of 50, which reduces down to 11/25. And our last one, for blue, green, or yellow, we have 10, or 14, or that, over 50, which is a total of 30 over 50, reduces down to 3/5. That's what those or means there. Okay, or is to add. So the next one, you have to make the table, complete the table, and list the sample space of the event, the sum of rolling. Sum is what happens when we add things together, 2 dice. And then use the table to answer the probability problems below. You can do a fraction, nearest hundredth, or a whole percent. Doesn't matter there. So to complete this space here, I'm going to do 1 plus 1 is 2. 1 plus 2 is 3, 4, 5, 6, 7, and then 3, 4, 5, 6, 7, and 3, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 7, 8, 9, 10, 11, 8, 9, 10, 11, 12. So quick little frequency table there for sample space. Okay, the probability of rolling a sum of a 3 or an 8. Well, 3 is here and here. I have 2 of those. Out of a total, how many options are there altogether? I have 6 by 6. I have 36 total. That's my number I'm working with. There's 36 outcomes I could get here. So there are 2 ways I can get a 3. And 8s, I have 1, 2, 3, 4, 5 ways I can get an 8. So that's 2 36 plus 5 36 equals 7 36 chance or probability of rolling a sum of a 3 or an 8. Probability of a sum of 4 and doubles. Well, 4s are here. Here's my 4 and a 4 and a 4. So that's a 3 out of 36. And it says and doubles. Well, first of all, I saw those are 3 there. Now, 3 and a 1 is not a double, and a 3 and a 1 is not a double. So my only one that would be a double would actually be this guy right there. So actually, looking at it, there's only one way I can do that, and that's here with a 2 and a 2. So I'm going to write down 1, 6. Next one of the dice shows a 6 given the sum is 7. So looking at my 6 here, I have one way that happens on this side, or this dice could work too. So I end up with actually 2 of the 36. Or 2 out of, probably one of the dice shows a 6 given the sum of 7. So that's just going to be, 2 of 6, so 1/3 for that guy there. There's 2 different ways that's going to happen. Rolling doubles or a sum of 8. So rolling doubles, that can happen 6 times, right? I can get doubles here, 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 here. So doubles can happen 6 out of 36. And a sum of 8, and it's an or. 8 is going to be 1, 2, 3, 4, 5. 5 there. 5 there. However, I want to be careful here because if you look, I do have a place of overlap. So I have to subtract that 136 because I can't count that twice. Alright, so that's what that's for. Because there's an overlap there, I have to get rid of that 1 that overlaps. So 6 plus 5 is 11, minus 1 is 10. Oh, I'm so sorry, off my video here. Sorry, doubles is 6 out of 36, and 8s are 5 out of 36. I have to subtract the 1 overlap space to give me 10 out of 36, which can reduce to 5/18. Are the events in number 15 mutually exclusive? Nope. And why is that? There is an overlap. So they're not mutually exclusive because they cross over the same spot. It changes the outcome. Alright, let's look at the next page, number 17. Draw a Venn diagram. We have 100 kids going on a field trip. We have 55 in art and 60 in chemistry. 25 are in a combination class here. So that tells me I have 25 over here. I'm going to write out my chart here. I have art and I have chem. 25 are in both. So for the art, because I have 55, if I want to find out how many kids are there, I'll do 55 minus the 25 overlap kids. Tell me that there are 30 kids in art. And on the chemistry side, I'll take my 60 kids and subtract the 25 overlap kids, and I end up with 35 kids there. Alright, so I have 30, 25, and 35. How many kids are in art only? We're going to go with 30 kids are in art only. How many students are in neither art nor chemistry? Oh, I don't have that in my chart yet, because if I look here, my combination is 60, I have 35 and 35 in chem. Is that right? 35. So 35 and 30 is 65, plus the 25 overall becomes 90, which means that there are 10 kids that aren't in any of those classes at all. So how many kids do I have left? I have 10 kids not in those classes. Why did they get to go on the trip? I don't know. What's the probability that one of the 100 people picked at random would be in art or chemistry? Art or chemistry. So what I do is I look at my art number. My art number is 55 out of 100. My chemistry number is 60 out of 100. I have to subtract the overlap. That's the 25 out of 100. Okay? And that will give me my answer. So 55 plus 60 minus 25 is 90 out of 100, right? Which is what I have there. And I can reduce that down to 9/10. Number 21, what's the probability that one of the 100 people picked random would be both art and chemistry? Well, there were 25 of those. So we're asking what's the probability of one of those 25 people out of 100 getting picked? That would be 1/4 probability there. Okay, moving down to the bottom here. We have C at a probability of 0.65, D at 0.6. They are independent. So what's the probability of C or D? That means to add, so 0.65 plus 0.6, right? C or D. And we have 0.65 plus 0.6. And how did that end up there? That's interesting. C and D are independent. Huh. That doesn't make a lot of sense there. They get sorry about that. Wasn't interesting. Something's not quite right with my math here. The answer, they subtract a 0.39. I wonder where that comes from. Sorry, I'm on pause here and I can't pause my video. Well, don't worry about that for now. Anyways, somehow it comes up with 0.86. We'll come back to that one there. So they come up with that answer. Not quite sure how that got there. So the not part is 1 minus 0.86. So we get 0.14. And this one here, we have an and, so 0.65 times a 0.6, which will equal 0.39. 0.39. Oh, that's what it's going to be. So the 0.39, you have to use this number to come back over here. So let's do this. To find out probability of C or D, they want you to do the C 0.65 plus the 0.6 minus the 0.39. And that's where you get the 0.86. So subtract the and value. So one of the first things you probably want to do is go ahead and multiply those together. When you multiply them together, you get that 0.39, and you can use that down there. Okay, so C or D, it's this or this minus the and value to get 0.86. That makes sense. The events E and F are mutually exclusive, which means that they are not going to have any overlap at all, right? Mutually exclusive, no overlap happening for those guys there. So on my paper, let's flip it over. We have these guys here. So there's no overlap, and because there's no overlap, I can just simply add them up. E is 0.75, F is 0.2, so we end up with 0.95. If it's not E or F, it's 1 minus 0.95, which equals 0.05. And then E and F, we can't do it because they are not mutually exclusive, so it's 0, because they are not mutually exclusive. I'm sorry, it's because they are, I apologize, they are mutually exclusive. You can't have both. It means if your Venn diagram looks like this, E is here, F is there, they would never overlap, so it's 0. All right, moving on to the last section. Here's a two-way table below to find the probability of the different events. We're going to find out the probability first of a car or a blue thing. Being car or blue. There are 300 total. So car, we have 100 cars out of 300. Or a blue thing, we have blue vehicle, we have 100 of those out of 300. Right? Now, that's great, but I have to make sure that I subtract any of the overlap. Right? Any overlap. My overlap is going to be here at a blue car, which is 67. So subtract the overlap from the total number there. So 200 minus 67 is going to equal 133 over 300. So it's about that overlap that you have to be careful about when you're adding up your values. So there are 100 cars, 100 blue vehicles, subtracting the overlap, there are 133 possibilities of having that selection happen, doing this or that. Okay, red and a van. All right, so red and a van. Erase my marks here. So red and a van, the red is here, the van is here. I have a total of 8 red and vans out of 300, and that can reduce to 2 over 75. Okay, next one, 30, probability of a truck or a van. So a truck is going to be over here. There are 120 of those out of 300, plus a van, there are 80 of those out of 300, which means I have a total of 200 out of 300, or 2/3 if I reduce that. Again, there's no overlap when you go across the row, so I don't have to worry about subtracting anything. Don't worry about that overlap figure like you did in number 28. Number 31, probability of it being blue, so this column, and white, this column. Well, they don't overlap, they never happen, so the probability of that would be 0. Not going to happen. Okay, what's the probability of it being white given that it's a van? Well, the van, remember, is my denominator. It's the given point. So the van is going to be 80, that's my denominator. And the chance of being white, well, there are 48 white ones out of 80, which reduces down to 3/5. And the last one over here, probability of being not a car given that it's not white. My not white given, not white. Well, this is the white part, so not white is all of this. So not white is combining those two, that's 125. So of these things here, what's the probability it's not a car? Well, those are these figures right in there, not a car. Which ones are not a car? Those guys are not a car. So 24 plus 9 plus 4 plus 8, that equals 45 out of 125, or reduces down to 9 out of 25. Okay? So we're going to take the not cars in this section here, and that's what that means. If one car is chosen from the lot, what is the probability it is blue given that it is a van? Okay, so the given it's a van, that's our bottom number, 80. And given what's the chance it's blue, and look over here, it's 24 out of the 80. And that can reduce down to 3/10. You write that out as probability of blue line van. And number 35, the last one, probability of it being a van given that it's blue. In my given value blues, I have 100 of those. And the van numbers in that section, there are 24 of those, which becomes 6 over 25. Sorry, maybe I should have written there. So there's my blue is 100, and there are 24 of those altogether, becomes 6/25. All right, hope that helps a little bit for your review. Good luck this week.